So this is actually, Lucas, the biggest topic that we'll cover. So it's going to be most of next term. There's 4 topics in Unit 3. Bivariate data is quite big. Time series analysis is a bit smaller. And then after that, we've got an earth geometry topic and a sequence and series topic, which will be really easy if you did methods in term 1. So they'll be in term 1. So that's the first thing. This is probably the biggest, and it's the one the PSMT will be on. So a couple of things that you need to be aware of. Firstly, bivariate data. Bivariate has the bi at the start, bi, which means 2. So when we talk about bivariate data, we're talking about comparing 2 variables. When you did a topic earlier this year, possibly, or you did a catch-up topic in term 3 on univariate data. Univariate data was all to do with 1 variable. So just a set of numbers, you could find mean, median, mode, standard deviation, you could draw box plots, etc. Bivariate data is when you're matching 2 variables. So you might get 100 people and get them to measure their arm span and their height, and then compare the arm spans and heights and see if somebody who's taller has a bigger arm span or something like that. So you're pairing up 2 variables, comparing them and creating some sort of statistical analysis on that. This leads naturally predominantly to scatter plots, because scatter plots are drawn where you have at 1 variable against another variable on 2 axes. So that's what we're going to be dealing with, scatter plots mostly in this topic. But what we're going to go towards is scatter plots, lines of best fits, and regression lines for scatter plots, using that to make predictions, and correlation coefficients to look at the strength of the correlation or the link between the variables. So here's some examples. But again, I've stolen these from Miss Wartell. So effectiveness of a new headache drug compared to the effectiveness of an older one. So you might compare those 2 drugs together in certain situations, say with test cases. Age versus height of children is an obvious one. Years of education and how much you get paid. And age group, musical taste, for example. And so they all provide us different situations. The last one's an interesting one. Age group, musical taste is one that, if you consider it, it's quite hard to plot that one on a scatter plot. So we're going to have to look at some other variations as well. And we're going to talk about why that one would be hard to plot on a scatter plot. Can anybody see why it would be hard now? Pretty much spot on. So which one's the problem type? Which one's the problem? Musical taste, because it's not going to really have a numerical scale. So doing that on a scatter plot's not really going to make sense. So we'll talk about those types of things as well. And here's the main goal, to find an association between 2 variables being studied. So here's the first one, categorical and numerical. This is the big picture. The big picture is you either have categorical data or you have numerical data. And you'll have to think about your types of data individually. Bivariate data brings together 2 different types, and we have categorical and numerical. You've seen this before. Categorical is data that's in categories. That's why it's called categorical data. So anything that's represented in categories, where there's, and it could be ordered categories, it could be unordered categories, but where it's not numerical. That's really the way I think about it. Numerical data is data that's represented on a clear numerical scale or a measurement of something numerical. If it's not that, it's probably categories. If it's a colour-based data or musical taste or way that you get to school, which type of transport, for example, they're all categorical data. And some examples there. And then we split the categorical and numerical up. So these are really common multiple choice questions. So you have to know these. They could come up as a multiple choice question in your external exam. This type of data is what? So first in numerical, this is the easy one and the one that you've probably seen more of. Discrete and continuous. Discrete is countable, continuous is measurable. So when we're talking about height, for example, you measure height. That's continuous because that's on a scale that's got infinitely many steps. Whereas discrete will be when you count. If I'm talking about the number of students in a class, well, I have 17 students in a class or 18. I don't have 17.6, so that's a discrete variable. It's numerical still because it's counting numbers, but it's discrete. Discrete is countable and continuous is measurable. Again, I wouldn't be writing this down and trying to memorize it necessarily. You've ruined your book already, have you? I wouldn't be writing this down and trying to memorize it. I would have this written down somewhere and just pin to your wall wherever you study or in your book, pull it out, all these little facts here. And as you're doing things, just read them and refer to it and refer to it and refer to it, and then one day you'll just realise you know. You never have to refer to it again. Categorical can be either nominal or ordinal. Again, the nominal is a bit harder to link, but ordinal relates to if it's an ordered set of categories. So musical taste is not ordinal. But for example, if I gave you a survey and said, do you find using the OneNote helpful? And you can have strongly agree, neither, disagree, strongly disagree. That they're categories, but they have a distinct order. So that's ordinal data if it has an order, and if it doesn't have an order, it's nominal. So then it's just whatever. Eye color doesn't have an order, and be careful there because you might say, well, every time I look at an eye color survey, the colors are represented in alphabetical order. Well, it's alphabetical order doesn't really count. It has to be an order that naturally occurs within that set. Gender would be nominal. Coffee size would be ordinal. Yeah. So I'll write that on there. Nominal, ordinal. Number of siblings over here is discrete, whereas height is continuous. Any questions on that? I still have to sit and think through the definitions when I'm doing these questions, and maybe I don't do it that often anymore, but it's just have those definitions down, make sure you understand them, and then refer to those definitions. Don't try and memorize them, just refer to them often, and you'll find it's there when you need it. So there's an example here. I know that a couple of people are still writing it down. I hope that's not too small. I'll just bring this up a bit. So what types of data are the following 5 things? First, we recognise whether it's categorical or numerical, and then once we've chosen that, we consider is it ordinal, nominal, or is it discrete, continuous? So there should be 2. We should be giving it 2 definitions here. So let me just write that down. We start here with our data, and then we have either categorical or numerical, and then in there we have either ordinal or nominal, and in numerical we have either discrete or continuous. That's a diagram, and if we get to the bottom of this branch here, we'll say it's numerical continuous or continuous numerical. So weight, what's weight? It's numerical, continuous. And favourite colour? I can't hear very well. Categorical and nominal, good. Support for same-sex marriage. I think it's ordinal. It's a bit tricky. Like I go, oh, is this ordinal? When there's only 2 options. Well, if we threw in a third option, maybe, then it would clearly be ordinal, wouldn't it? So that's what you got to think sometimes. It might be hard to see is 2 options actually ordinal, because if you swap the order, doesn't matter, not really. But if maybe was a third option and then you had maybe, yes, no, that would be the wrong order. So then it's ordinal. Number of pine trees per acre of forest. So it's numerical because it's going to be a number, and it's discrete because presumably we don't have half a pine tree. I'm assuming they're going to count as they go. I mean, I don't know. Maybe they'll say smaller ones are worth half or something, but probably not. Attitude to lowering the driving age. Categorical, ordinal. Okay. I'm just going to go down a little bit more. Here's some notes that Ms. Wartel wrote, which I think are quite important. So when you first do, like the exercise you're about to do is just going to say, here's stuff, is it categorical, is it numerical? They're just going to ask you to analyse stuff. Later on, and we're going to expect this in your exam in Unit 1, for example, and we'll expect you to be naming things in your PSMT as well. Later on, you will get a question that's this big, and it's about bivariate data, and you have to make a scatter plot, and you have to find a regression line and do some analysis based on that. Part of that process is going to be identifying the types of variables. To do a scatter plot, you're going to have to identify that both variables are numerical. Or maybe, at worst, one of them is numerical and one of them is categorical ordinal. There has to be order though. Whereas if you don't, you might do a two-way table for a non-numerical situation. So you'll identify the type of data and then do the process that follows that. So that's really important. So for example, this one here, this is the first example that was on that list earlier. The effectiveness of a new headache drug compared to an old one. What types of variables are we comparing? So what are we expecting them to be? Could be. I think it probably is like numerical continuous, in that it's probably measured as like a percentage effectiveness, or it could be measured as a time that it takes for a headache to get to a certain level of being gone. But you know what? It could also be categorical. So we don't know enough about the data. They could just survey people after an hour and say, has your headache changed? Yes, no, maybe, or give a bigger scale. So we don't know. It'll definitely be ordinal in some description, but it could be categorical, ordinal, it could be numerical. So I'd suspect it's going to be something like this. And effectiveness in this situation is being identified as time. So if it's identified as time, then it's definitely numerical continuous. So time, we measure to the newest minute or second. It's still a measurement. So time, numerical continuous. But then also we have a drug type. So we're measuring the time it takes for a headache to go away based on the type of drug. That type is going to be categorical and it's going to be nominal. There's not going to be an order. There might be an order. Again, we don't know everything, so that's not numerical. So categorical, numerical, there might be an order. It might be something like drug trial 1 and then they fix something up. It might be drug with this percentage of whatever it is, the drug that's actually effective inside it, and then they raise that percentage by 0.01, raise it by 0.01 again. There might be some order associated, but while we don't know that, we're just going to assume it's just different types of drugs. So that's categorical numerical. So let's just talk through this quickly. For each of the following questions, determine if they involve investigation associations between one numerical, one categorical, two categorical, or two numerical. This will be the thing that you have to identify when you're solving a question. Are younger people, measured in years, more likely to believe in astrology than older people? So years is a numerical. Yes, no is a categorical. So if I call these 1, 2, and 3, this is option 1, a numerical against a categorical. Once you've identified that, you go off and follow a particular procedure for analysing that data. Do students spend more hours studying each week to get higher test scores? So the two variables are the hours spent studying and the test scores, and they're both numerical, yeah? So that's an N and that's an N. They're both numerical discrete against numerical continuous, but they're still type 2. That suits a scatter plot quite nicely. Are people who have a driver's license more likely to be in favour of lowering the driving age? So this is a yes-no driver's license. And are they more likely to be in favour? It's not a numerical thing. It's probably a agree, strongly agree, etc. That's also continuous. So this is option 3. And that was a very well-written question where the answers were 1, 2, and then 3. That's always good. Are there any questions on that? Is that all right? Is it? Oh, it is too. I'm not very good with numbers. Any questions on that? Okay, last little bit of a definition here, and then I'll leave you alone for a little while. So this is the type of thing that could come up as a single mark multiple choice or a single mark at the start of a scatter plot type question. So when you define your variables and you build either a two-way table or a scatter plot, we can identify whether one of them is the explanatory variable or whether neither of them is, or whether perhaps both of them are, depending on the situation. So you have an explanatory variable and a response variable. The explanatory variable is like the independent variable that you've learnt about before. It's the thing that isn't affected by the other variable, whereas the response variable is affected by the explanatory variable. So the language they're using here is which variable can be used to explain the other one. So, for example, in the question earlier about the effectiveness of a drug, the time that a headache takes to go away doesn't explain the drug, but the drug that you use will explain the time that the headache takes to go away. So the drug is first, it's independent, and then the headache takes a certain amount of time to go away. So that's explanatory against response, and it's about what we use to predict. And you'll obviously, if there is an explanatory variable, and there might not be, but if there is one, that will be your x-axis on a scatter plot. So we're going to keep that in mind as well. So here's just a question about which ones are which, and then there's the textbook stuff. Example 3, you want to investigate whether there's a relationship between house price and location. What types of variables are we comparing? House price is a numerical, and it's a price. So it's probably, we can probably call it discrete, because we've got it down in the nearest cent, and then there's nothing below, there's nothing between 2 cents and 3 cents. If you ever find a house that costs 2 cents or 3 cents, tell me about it. And location is a categorical, and it's going to be nominal because like that's probably not going to be ordered. But again, maybe it's going to be ordered, or maybe it'll be that we talk about places, locations in terms of size of cities, or maybe in terms of temperature, and we're looking at whether the temperature affects the house price or something like that. Probably not. Secondly, which one is the explanatory variable? Which one is the response variable? So that's what should happen. And you'll know that there's a lot of variability here, but typically speaking, if you name a suburb, then there are people out there that can tell you whether that's going to have good house prices or not. So it obviously explains house prices with a fair bit of variability, depending on the number of bedrooms and all that kind of stuff, but it explains house prices to a point. Any questions? That's it. So you said, let's not do any work today, and I said, let's do something easy, and I think it's easy. So, what is it?